Hello, everybody, and welcome to today's vOLTHA TST. Thanks for joining. As usual, the call is public and recorded and will be shared live on YouTube. So please be mindful of the comments you make and the information you share. So today, just first of all, I want to bring up the dates for the release. So as you guys know, June 30th is the target for our release. We just had the operator TST meeting, which agreed that if a little bit more testing is needed, we could go for a couple days more. But I would like not to use those days and get to the release June 30th. So for that, I would like all the changes to go in by next Monday, end of business Pacific Standard Time. That gives us about 4 days of work to complete major code changes. Where major code changes, I really intend to say all the big changes that are needed for the storage that we know we will want to go in, and the multi-unit stuff. That needs to be merged before next Monday. And then so we can have some time to do bug fixes and further testing. So any comment? Okay, then if not, please go through your patches, make sure that they are up to date, they're tested, they're functional, they work, and all of that. And if you need reviews, ask for them on the vOLTHA channel or ping me directly. I did a pass on the JIRAs. Please take a look at them here. There is a filter where you can see all the 2.8 JIRAs. Hopefully, I need to find. You need to be logged in for this to work. But you can see all the JIRAs for the 2.8, the progress to do. Please, if there is something that's assigned to you that you know what the status of it is, just make sure to update it as much as we can. Okay, next, as per usual, I would like an update on the etcd stuff. I know Girish has been working very strongly on this, so a huge thanks goes to him and David and Ken as well. Girish, do you want to give everybody the current status of things? I know you posted it on the channel and it seems to be a fairly straightforward small update.
Yeah, there are many things that we did in the past week. I don't know where to begin. So the first thing was David and Ken provided the etcd client pool implementation for me to try out. So the thing was David, probably David can comment here. So I think the assumption was that too many etcd clients connecting to etcd was slowing down things. So there was a pool created with a limited number of etcd clients, and these clients would be reused to make the connections to etcd. This itself didn't really help with persistence on ONF hardware, but things worked on the AWS cluster with NVMe disk, but it was not always consistent. We did see timeout issues in certain tests. So then we attempted a few other enhancements. One was to try out a static resource pool allocation. Basically divide the resource pool statically among all the users, all the subscribers on the PON port equally, and just statically assign the resource to all the users. This logic itself worked, but still there were timeouts seen. So basically, now we didn't see the resource, timeouts during resource allocation because they were static, but there were timeouts in other places where we were trying to, read write to the etcd key store. So basically this, gave me a feeling that, the other thing is, I mean, if we disable persistence, things worked fine. So I don't think there was any issue with locking or any such stuff during resource allocation. It was basically the persistency itself on etcd that was causing the problem. So then Maher had a suggestion that which was actually true. So the resource manager was being, and tech profile instances were being shared across all the pawn ports. So this meant that the logs that were associated were shared across all the pawn ports, which was really not necessary. I mean, the resource pools are actually unique per pawn port, so it makes a lot of sense to have the resource manager per pawn port. So I did that change to make resource manager instance per pawn port. This meant the logs. There is much less contention for the logs by a factor of the number of pawn ports. Well, the logic itself worked. Again, there were still timeouts that were seen. The timeouts, the time taken to access the resource was much less than before when there was a lot of contention, but still there was a significant amount of time. And at certain times, I did see the timeout where read-write core failed to hack the flow. I just took one of the failed scenario, and it was taking about 8 seconds or so to acquire the resource from the resource pool. I also had the logic in etcd that Ken submitted a long time back, where it's not merged yet, but the logic in the etcd client code to retry put, get and delete key values from etcd. So sometimes we see under high load etcd is throwing some timeout errors. I mean, there are a lot of error codes that it throws under high load. So there was a logic in etcd client code in vOLTHA libcode to retry the operation. So I had that code as well. So this logic was working perfectly fine. I mean, when it used to retry, but yeah, I mean, we did see the timeouts in the retry code under certain instances. Well, these are the things that we tried. So I was just thinking I'll go back to using the etcd client pool right now. I mean, I dropped that idea while working on other set of enhancements. Now, at the moment, all the enhancements that we could think of are already in place. I don't really have, next big enhancement in my mind. So I want to go back to trying out the etcd pool probably and see what happens. Any questions, comments, suggestions?
No, I think this is right. Why my take is that we throw everything we have at it and just see if it works. You also mentioned in one of the channels we have that there are some hard-coded timeouts in the adapter that cannot be increased. Is that the case?
Oh yeah. So I was saying that with a 30-second timeout read-write core timeout for flow add, I think there are certain hard-coded timers in code. For example, in OpenOIN, you go. It tries to update something to the etcd DB, and there are some hard-coded timeouts to get the response back. I have to check the code because even before 30 seconds, sometimes I used to see timeouts. After code. So probably there are some local timers there that we'll need to adjust, or they need to be configurable as well.
And again, I mentioned this in chat, when I was seeing timeouts happen, reported faster than my set timeout, that was some of the errors I was seeing when there were some conflicts using the same connection to etcd that the pool kind of got rid of. So etcd seemed to be reporting timeout issues, even kind of internal timeouts. So I don't know, some conflicts internally reported as timeouts. It's very strange.
Mm-hmm.
So you, David, so David, you think that it could be an internal issue that we have?
Well, what I've seen, I mean, there are clearly hard-coded, well, I don't know, clearly, but there are likely hard-coded timeouts that need to be addressed. I was just saying in my testing,
yes,
that I would sometimes I'd have a timeout set at 10 seconds, and I'd get a timeout error back from a call, but the timing checks around the call said the call to etcd was actually under 10 seconds. It'd be 5 seconds. So it didn't make sense why I was getting a timeout. When I went to the pool, that went away in those cases. Now, does that mean there's an internal error? No. It could be that we blew past a resource constraint issue using the client multiple times. It could also be a code issue on our side, how we're dealing with context. I mean, there's lots of reasons it could be. And I never whittled it down because the pool did get around it. So I think it's going to have to be both, go through, find out the hard-coded timeouts, eliminate them, as well as perhaps at least run it with the pool and see what that changes the outcome.
Yes, I agree to both of these. I see what you mean. I think reintroducing the pool is definitely worth it. And removing the hard-coded timeouts is also a good thing. In the core, and Ken, correct me if I'm wrong, but we do have one general thing which is called core_timeout, which sets the timeout for every call the core makes to a TCD.
There is one. There's a core timeout, but also there's a KV timeout as well.
Oh, okay.
Yeah, I need to double check which one gets actually used when we talk to etcd. I think it's the KV timeout, but I need to double check that, because very often when the request comes in, we use the core timeout as in the context of that request. So it could be a combination of both of them.
Okay. Yeah,
I've also been wondering if we're reusing context with the timeout over multiple calls somewhere.
That was something I was thinking also while we were talking right now, because we pass sometimes in these calls. What we do, we create the context at the arrival of the call, like from the northbound or from Kafka or in the adapter. And that gets passed along within the adapter, and we use it for a TCD as well, but that effectively gives us a much lower timeout because it already went through the code. Well, much lower, somewhat lower timeout because it already went through the code.
And that's something I think we need to check.
Okay. So as a recap of the things we need to do, I would say we need to do 3 things. Here, let me take away this. So use of the pool in tests going forward, always.
Well, I do worry the pool is hiding things, right?
Okay, so maybe we swap the order around.
Yeah. I mean, it'd be fine to try the pool and see if it makes a difference, but I do worry that the pool is hiding things.
Remove the hard-coded timeouts from the OpenOLT adapter.
I'm not 100% sure of this, Andrea. I mean, I think there was something when looking at the logs, but I might have not thoroughly analyzed. Yeah, if there is something, I'll fix it.
Okay, but in the adapter, sorry for my not knowing this, but in the adapter, do we have the distinction between the operation timeout and the KV store timeout?
Well, there isn't anything in the OpenOLT adapter. I was mentioning in the OpenONU adapter, so there are some. Basically, for each operation in a northbound request coming in, like flow add or some operation, so it starts a timer and expects the operation to finish within a certain time. That time may be significantly less than read-write core timeout. I mean, if you have configured 30 seconds, it may be significantly less than that. And
okay,
that's probably canceling the context and stopping all the operations. So we need to adjust that time.
Mm-hmm. The last thing was forgot to check within the context.
Yeah, I didn't get the last part. So what was that? I think I missed briefly.
So maybe Ken or David can do this, but if I understood correctly, so per each call we have a context.
Mm-hmm.
If that context gets passed along very much and then gets reused for a TCD, we're effectively lowering the time we allow a TCD to work for, because we already spent time in the context before arriving to the TCD.
Mm-hmm.
Or even if the context is used to make multiple etcd calls without resetting the timeout. It's that type of thing. I just did a quick grep on the code base. I don't really see any hard-coded timeouts if I did the grep correctly.
In the OpenONU Go adapter?
I did both adapters, the core and the libgo.
Okay.
Well, that's good. Yeah, because as I said, I haven't thoroughly analyzed it.
Yeah. Again, I may have done something wrong with my grep, but
one work less for us.
Yeah.
Okay. Okay. And then all of this needs to be tested on the ONF hardware.
Yeah, I mean, I have some issues with Jenkins. Andrea, as you are aware anyway. So
yeah,
and there is some trouble with the AWS cluster. So I have to do all tests on ONF hardware.
Yeah, I don't know. I'm sorry, I don't know how to bring that back up. I just don't.
Okay.
Yeah. So on that's all I had on the ATCD stuff. Is there anything else that you guys want to bring up on this? Any other next steps that we can make? Or should we continue the work on this and chat on it on the persistency channel?
Yeah, I mean, at this moment, yeah, I don't have anything to discuss, so we can chat on the persistency channel if something comes up.
Okay, David, can I ask you to check this context reuse proper configuration of the context?
That's like a complete code review of every context in the code. Right.
It get done by whoever own different components.
Yeah.
It's because it's extensive. Like this is something that we definitely do in a core where we make sure we avoid reusing of context. But then you have to go through every single functions to make sure it doesn't get reused. So I think it would be better done by maybe someone that is very familiar with vOLTHA and OpenMenu.
The other way you can check some of this is create a temporary libgo, which basically creates a context right before it makes the actual etcd call. So it doesn't use the context it's passed in, creates a new one, makes the etcd call, and then cancels it, right? So you're guaranteed that there's no reuse, and run the tests. Build new libraries or build new containers off that lib and run the tests. And if we're still seeing these timeout errors, then it's something else. If the errors go away, then it says somewhere it's likely that a context might not be used correctly. So rather than a code observation, kind of a code review, I think there's an empirical test we can do to get some indication.
Can we have this logic in the etcd client? I mean, basically it creates the context and just cancels it.
Yeah, that's what I'm saying. It would be in the etcd client, right around the call, right around the actual etcd call. Mm-hmm. So we change it for the whole code base, essentially right where we're doing the pool, right?
Yeah.
Is it recommended to do that in the sense of when you get a request coming in from northbound and they set the context timeout, this is for the request to go through completion. Like for example, in the core, it's the completion means that data has been written to a database within the timeout that the user has specified. So if we go and change the context now from the etcd side of things, it's we're kind of breaking.
I'm not suggesting we make this a permanent change. I'm suggesting as a test, we run it this way. And then if the timeout goes away, then it says we may be doing something wrong with context. But if we make this change and the timeout exists, then we know that it's not the issue. So I was just trying to think of an empirical way we could test this to see if this was even an issue.
Well, within etcd, when you get the call with the context coming in, can't you then create a context with that incoming context being its parent?
You can. Okay, again, if I have a context that comes in that has a timeout and I create another context with a timeout on it, when the inner timeout expires, the outer one will too.
Okay.
So again, I'm suggesting we just do this as a test.
Okay.
to see if it's a context issue. And if we do this as a test, I think we should probably fairly quickly be able to determine this may or may not be an issue, right? If the timeout goes away when we do this, the timeout error goes away when we do this, then we need to look at it deeper. If the timeout continues when we do this, then we know that we're not solving the issue that way. I think it's more reliable than trying to do a code review, even if someone who really knows the code.
Yeah, fair enough. One question I have maybe to Girish. Girish, you were mentioning that the etcd response was around like at times 5 seconds, right?
Yeah.
So let's say we go to the approach where we're recreating a new context with etcd. So now suddenly the 5 seconds is no longer in that picture. But then if we have a timeout of 10 seconds, then something else is taking that 5 seconds.
Yes.
So if we increase the timeout, we should not see any problem, right? But we're still seeing problem.
Yes, you mean the read-write core timeout?
Yeah.
Yeah. There is some inherent problem elsewhere. Yeah, of course.
This is why I'm suggesting run this test to eliminate the possibility, right? once you run this test, we can eliminate the possibility that that it's a context freeze issue. And it may be a pool, the concurrent usage of the connection issue, or at least one that we've seen surface that way.
Yeah, makes sense. And it's, any test that clarifies one part of it is good.
Because, you know, as Girish said, when he sets a timeout for 30 seconds, he's still seeing timeouts far less than 30 seconds. And if all the timeouts are set at 30 seconds, we shouldn't be seeing that.
If we set timeouts like 2 minutes and then we're still having problem, then it's I don't think it's actually.
Yeah.
Yeah, I mean, that's another interesting thing that I would like to try. I mean, just for the sake of fun, you know, make core timeout as 120-second and see what.
Sake of fun. You have an odd sense of fun.
You know, while I'm working some change, just trigger and it takes 10 to 15 minutes.
Yep.
Okay. Okay, then I think we have the next steps. Sorry, I forgot to say that we still need to. So this timeout that we want to try with 2 minutes is across all components. Right?
I thought rewrite core timeout. I'll have to look at, you know, what timeout configurations the adapters expose.
Okay.
Yeah, I would suggest to increase all the timeout everywhere.
Everywhere, yes, everywhere.
Yeah.
Okay, yeah.
KV timeout for the core is a KV timeout, and then there's also the core timeout. Just increase both of them.
Okay, good. Anything else on this?
No.
Okay, then let's do this, and let's keep chipping away at it. Hopefully, we can get this done soon. In terms of patches, guys, what needs to be merged? So there is a review on the vOLTHA Protos and vOLTHA libgo from Girish that we need, right? These two need to be reviewed, right?
Yeah, but there's still some churn going on in vOLTHA libgo. So yeah, I mean, at least the protos could merge. There's no change that I expect there. It's done.
Okay. So please review this.
Go
ahead.
Yeah, vOLTHA libgo, people can have a look at that, but some more changes may come in.
Okay. Sounds good. Okay, so next up is a small topic. It was inserted some time ago, but now actually is resolved for now at least. So there was in part of the work for the multi-uni that Mahir and the rest of the folks were doing at Netsia, they did some great work. And one of the patches was actually bringing in a change in the mask that we use for deciding which ONUs are reported as enabled from the OpenONU adapter. Right now, we only have one, meaning that we only report one ONU to be active, one uni of the ONU to be active at a time. So what that happens means that, what that means is that we don't have multi-uni support right out of the box, because that constant was hard-coded before. But we have changed that from being hard-coded to being configurable via Helm charts. So if you need multi-uni support, you enable it via Helm chart, and that enables you to have all the unis on your ONU to be active. Instead, if you don't want it, you just leave it as default, and it's going to be just one uni enabled at the same time. Any questions? Okay, good. Then I'm progressing forward to the next step, which is the reconciling failed situation. So if you guys remember, we introduced the reconciling state. So right now we have the state. We put an ONU or an OLT in reconciling state. We ask the adapter or to reconcile that. Let's take the case of the ONU. But we don't have any mechanism to handle a failure of reconciliation. Meaning that if the adapter tries to reconcile that ONU, it comes back to the core, says, hey core, I cannot really handle this reconcilement. We don't have neither a reconcile fail state, neither a mechanism in the core to retry that reconciliation. So I would like to hear people's thoughts on what should we do here. Should we put in place, first of all, should we put in place a reconcile state? Should we not? Second, what do we do? Do we retry to reconcile? Do we just put it in fail state and let the operator handle it? Like, what's the thought of the people in the call?
If it's in a failed state, what can the operator actually do to handle it?
Delete. Delete it, it should come back. Or you should perform like a reboot of the ONU, which in turn does a complete MIB reset, for example. I don't know, I'm just throwing out ideas. I'm not saying I have the perfect solution here.
Typically, cause an ONU not to be reconciled.
Sorry, what?
Typically, like in a field, like suppose we send a reconcile request and that ONU cannot be reconciled, what would be the common reasons why we can't reconcile it? Because a core will do a retry, but if it cannot be reconciled, does it make sense for the core to do a retry?
There's many reasons why it cannot be reconciled. It's I don't know, unreachable, or just the MIBs are in not correct state. The counters are telling us that there is no proper configuration. I'm no MCI expert. I think there are plenty of reasons. The core might want to retry, but I'm also okay saying we don't retry, we do something else. So I'm open.
Does anybody in the call know the likelihood or probability if a retry is triggered of its success? Is it more often than not going to succeed, or more often than not going to fail?
It's a good question. I personally don't. Maybe Chip knows more than everybody on this.
Well, I have not seen a reconcile fail, at least in the lab environment. Probably one likelihood of that I would see where it failed is it's not able to make a connection back to the device. Well, in that situation, unless the device becomes reachable again, you would continue to see reconcile failed on retry. Probably we could have, a configurable number of retries and then report it back to, northbound systems.
So if a device loses connectivity, doesn't that go into an LOS state anyway? So if we actually know it's a connectivity issue, we shouldn't retry. We should know that we're disconnected. And when a device is reconnected, we should always do a reconciliation.
Yeah, I'm not really sure if some of the OMCI state machine works that way. So currently it does not support the stop and wait protocol. So say you lose, the OLT has some issue with OMCI round trip, then I'm thinking the current way the OpenONU sends out requests is it's basically from a queue. When the Kafka response comes back, it sends the next message, regardless of whether it got a reply or not, to that request. So I'm not sure what it does in the case of say a timeout, Kafka timeout for an OMCI. Does it keep on going and go to the next request? And then if you get connectivity back at that time, then it may finish programming a sequence, which of course could fail because it may have missed something. And then the OpenONU device adapter doesn't do support a MIB audit capability. It's just mainly a MIB data sync related. So I think it could easily get into a hung state. But as Grish mentioned, doing the typically when you have ONUs that go bad, even like a rogue ONU, you typically you do resets or you do retries, and at a certain point you just basically say you have to start over with that ONU.
So if we get a reconciliation failed, is it safer essentially to reboot the device at that point? Or put it in a state and let the operator manually reboot it?
Yeah, we probably need to have like Michael or somebody from Adtran who would probably know what the best conditions would be.
I mean, if reconcile fails because we cannot reach the device, even the reboot wouldn't work because you cannot reach the device.
Yeah, you'd have to do a clone reboot, and that's not where we really want to go.
Well, we can also say that if we could put in place some retry mechanism. We do a retry for like a reconciliation 5 times. I'm just throwing out the number. Then we might try to reboot the ONU. And well, if that fails, we leave it in reconcile fail state. And that's just a signal to the operator, hey, this needs a hard reboot, or like go figure out something.
Yeah, I'd put the retry at a lower value, 3 or so, because if it's not reconciled, you have a subscriber out. So why prolong it? Each retry, I bet you will take, tens of seconds, if not more. So going much past 3 is a bit excessive. And of course, they can increase it if they want to, if it's configurable.
So retry 3 times and then go to a reconciled failed state and let the operator deal with it. Is that what you're suggesting?
Yeah.
I thought there was a reboot in there, but maybe I'm wrong.
No, I don't think we should reboot from.
Okay.
I'm not sure if we should be rebooting the device.
Yeah, I kind of agree there. Don't automatically reboot. Let the operator do that.
Okay.
Are there some conditions?
What about mid reset? because that's not a reboot. If the device is reachable, a MIB reset.
Well, it's still service affecting, so
it is. It is.
He could be in a bad state, but still passing subscriber data. You know, that 911 call could be up and active.
Okay.
Are there some conditions that the adapters knows for sure that a retry will not work? Because if there are those cases, then there's no point to do a retry.
Well, you know, that seems too complex. You know, how would that adapter indicate the core that it cannot in no way reconcile?
Yeah, I don't know. I'm just saying if there's none, that's all right, because the core we'll get a failure and we'll do a retry, and then if we have a 3 times retry, then we'll invoke it 3 times.
I don't know that. I don't know the answer, you know, for that 100%. But you know, in the first iteration, maybe, you know, just keep it simple. Just say reconciliation failed, and retry a few times, and then indicate not found.
I got to be honest, with today being the 15th and we're looking to code freeze, was it 21st? Yeah. I'd almost say, look, if it fails, mark as reconciled failed, and let the operator deal with it. And then in the next release, we can determine if we want to do retries or not.
Okay. So
yes. I second this, and let's keep it simple. And if it fails, right, that is failed. Okay.
I agree. So what we are saying is we introduce a reconcile fail state. And if the adapter has done his thing, because it does try a few things that I know of, but we say if the reconcile fails, well, good luck. Yeah, up to you. We put it into reconcile fail state, and the operator does a hard reboot. It tries something else, up to the operator. Okay.
Can the operator do a soft mid reset as well?
I think that a new reboot via gRPC API is effectively that. It does reboot the ONU. It does reboot the ONU, but it performs also mid reset as well. So it's service impacting. Okay, so I'll talk to the folks at on the OpenONU Go call, and I'll let somebody work on the proto changes for this. Okay. Okay, good. Anything else on this topic?
Let's see. Yeah, Maninder, does that give you enough to go forward?
Yes, that is more than enough, I guess. I will start working on that.
Excellent. Thanks.
Okay, great. Thanks, Maninder. That's much appreciated. Good. Okay, last thing that I had on the agenda, which I just want to iterate over and make sure that people keep it on their mind and not like lose it because it's lower priority, is the PON ID. Even though we're not making any changes as of today, I'd like to have this somewhat discussed, as Bjorn was saying, because they need to take it into discussion internally at DT. So any thoughts that people have that we might start discussing, or you guys prefer just to remember this and then have a discussion possibly next week on next steps?
Yeah, so what is that? Is there some decision pending on this, you know, like from where should we configure the spawn ID, or what is that we want to discuss, you know, in the next meeting? Personally, it's clear to me on what is required, but what is that we would like to discuss?
Oh, how do we implement this? Do we implement it through vOLTHA, or do we implement it through the device manager?
Exactly.
And also, if we decide to implement it through vOLTHA, how do we deal with this? But even if we decide to implement it via the device manager, we will need a way for the pawn ID to be read by vOLTHA and used by vOLTHA, because we cannot generate it dynamically anymore. So
okay,
that's the gist of it.
Ultimately, this pawn ID has to be. I'm talking with respect to the OpenOLT agent plus BAL scenario. So ultimately, this has to be configured via the BAL API, and the configuration should go to agent, OpenOLT agent. So does architecturally, do we want device manager to talk to the OpenOLT agent, because that sort of is under the purview of the vOLTHA stack?
Girish, is it supported by BAL? And case support in which version?
Oh yeah, so BAL, I think there was a mail that Paul or Bjorn sent long time back. So they have a mechanism to send a PLO. So you have to encode the PLO message, and you form the hex message, and you just invoke an API on the BAL to send this PLO message. So it just transparently sends it. It doesn't do any operation on that.
Okay.
It's unlike other operations where you configure the flow, TCONs, or jump ports. You directly encode the complete hex message and form the PLO message and just invoke the BAL API. I can send you that information. I think I have.
Thank you.
So
yeah.
I think that given that we use this information in vOLTHA, and vOLTHA is supposed to abstract this information, and it kind of needs it very much, I would be okay doing this in vOLTHA, especially because otherwise, I don't really see how vOLTHA can learn the pawn ID because we configure it through the Open Device Manager, and then we read it through vOLTHA. That could be done, or am I mistaken?
Well, vOLTHA doesn't care about this pawn ID. The OpenID creates some identifiers, 0, 1, 2, 3 for this pawn ID, and vOLTHA stack formulates another set of IDs using this pawn interface ID. I think that's in the range of whatever. But the ID that we are talking about here is the 7-byte string. That is irrelevant to vOLTHA stack. That is something relevant only on the PLOM message, and probably to the ops guys who are, or someone in the field who is installing these devices. This has no relevance to vOLTHA stack or or in the northbound. So I really have confusions here. So these IDs need to be input to the OpenOLT agent, but OpenOLT agent is under the purview of the vOLTHA stack, but this configuration seems logical to have come through the device management interface. So there is sort of a conflict here.
Yeah, I think the device management interface might be a good common place to look at, because in the future, the device manager may be necessary to support various protection mechanisms, or to work mainly across both the adapters for like ROGO and U identification and isolation. So, a device manager being able to write, the PLOM specific information, give it to the OLT, of course, Open OLT to handle. But The configuration could easily be done through device management.
Mm-hmm.
I think what Girish said is exactly also our confusion. So, of course, the device manager might be the right place to handle that, but at the end of the day, we have to transfer it to the OLT agent and to the through BAL into a PLOM message, and that's exactly the issue we also have in our discussions. So that's there's a kind of it involves both. It involves the device manager, and it involves parts of vOLTHA, at least, let me say. And that's therefore exactly we need a clear way forward how we want to do it. That's exactly the question.
Actually, yeah, I don't know about other platforms, but having some knowledge about BAL, I can speak about BAL. So BAL can accept multiple connections. So while OpenOLT agent is one client to BAL, you can have multiple clients to connect to BAL. So you could still directly connect from device management application to BAL, and you can send out this PLOM message. That's not a problem.
Do you think it makes sense if we do a short meeting involving some relevant folks from Atran, Paul Wagner, and me from DT, and Girish, and maybe Chip and Andrea from ONF, and discuss that?
I think also some folks at Radisys that are developing the open device manager.
Yeah.
I mean, I could put it in the next device management interface brigade call. Which is in a week and a half. Not this Thursday, next Thursday. But I might call a special one for this Thursday if you guys feel like it.
To be honest, from my personal schedule, next week Thursday would fit better.
Okay, next week's Thursday would work fine. Girish, I'd have to ask you to wake up an hour earlier. I know that's bad, but the call it's usually at 7 a.m. Pacific.
It's kind of Monday.
So, Andrea, one point that I would want to bring up on this topic, although not technical, but if we choose the device management interface, we need to be aware of the fact that we don't really have an H4 device manager in the open as of today. So how do we implement in the community? So that would be a question.
So if this idea...
Another option may be accepting more than one gRPC connection in agent.
That's meddling things. I don't particularly like it. But one question that I have is, if this field is not configured by some external source, can we live with what we have right now?
I mean, there's nothing now. I didn't understand.
So the current solution has nothing, right?
Yeah.
So if nobody configures this value, we still live with it, nothing, and it works.
DT, I think in the deployments, they require this PON ID to be transmitted on the PLOM. I mean, if you don't transmit this, I mean, there is no way nothing is going on that PLOM. They need this, so we need to configure this.
Yes.
Oh, Andrea, you mean if you do nothing, then it works as it works today without any PON ID?
Precisely.
Yeah, why
precisely.
not? Why not?
Yeah,
I don't see an impact on that. Yeah.
So go ahead.
Go ahead, Andrew.
No, so to answer Amit's thing is, okay, we might not have it on the edge core, we might not have it in the public, but the public version still works if the operator that uses doesn't have this requirement. And we go and implement it on for example, in case of DT, on the outcome device, and DT has their requirement done. Am I making sense?
Yeah.
Sounds feasible.
Sorry, Mahir, I cut you off. What were you saying?
Yeah, is there a requirement to change this configuration dynamically in runtime, or is that only a startup configuration?
It's only configured once at the startup of the OLT. So of course you probably have to do it after a reboot again because it's not stored persistently on the OLT. But as long as the ONT is up and running, you don't have to do it again.
Okay. Then we perhaps may not need an API in northbounds of the agents or some other software on the OLT. This may be a configuration file or configuration file which runs the command line.
So, okay, let me schedule this maybe with a few experts from the team on next call for the open device management interface and see what comes out there, and we can take it further like that. Would that be okay for everybody?
Yeah.
Yeah, that'd be good.
Okay, perfect. Okay, great. Then given that we are at the top of the hour, I would like to thank everybody for participating today. I think we have the next steps on everything we talked about. So let's get those done. Please go through your JIRAs and your patches, and if reviews and things need to happen, just be extremely vocal about them and ask people to do them so we can get this done as soon as possible. And Girish, please do keep us apprised of the testing that you're doing on the cluster. Okay.
Okay.
Thanks a lot. Cheers. Bye-bye.
Yep.
Bye.
Bye. Thanks.